Hello, welcome to Advanced Composites. Today is the third day of the ongoing, that is the 7th week of this course, and yesterday we just finished a detailed discussion on case C and D and how the value of in-plane displacement, that is u, its sign changes based on the sign of B11. Today we will do another problem related to semi-infinite plates, and in this case the plate is not loaded in the transverse direction, but rather in the in-plane direction. So, let us look at the definition of the problem. So, let us call it case E, and here we have a plate which is fixed at one end, pinned at one end, but the pin connection is not rolling. So, it is fixed, and the other end is on rollers. Okay. So, this is the plate. The lamination sequence of the plate is 0 to 92. So, 0 layer is on the top, and then we have 90 layers on the bottom, and then this plate is being subjected to Nx at this edge. So, I am pulling this plate, and let us say that the value of this tensile N force resultant is N bar. Okay. So, the question is, so before we do we write the problem definition, the question is what are the boundary conditions? The boundary condition at this edge is u naught, v naught, w naught and mx naught, all of these are 0. So, at the negative edge, and at the other end n x plus is equal to n bar, which is known, n x y plus is equal to 0, because I am not applying any external shear. W naught is equal to 0 at x is equal to a over 2. So, I am still saying that this is positive x, this is positive z, and mx, I am not applying any external moment. The plate is free to rotate at the pinned end. So, it is having external moment at the positive edge is also 0. The other thing, like we did in the case of earlier, overall the length of the plate is a, and if I look at the cross section of the plate, so the height is h and the width is b. So, I say that a is very, very large compared to b. So, that is our approximation for semi-infinite plates. That is the approximation for semi-infinite plates. So, because a is very large compared to b, we can say that del over del x is equal to d over dx, and del anything, its differential in the y direction is 0. So, this is exactly the same thing which we had assumed in cases A, B, C and D, because this is a semi-infinite plate in the x direction. If it was in the y direction, then del over del y would be d over dy, and del over del x will be 0. So, now we want to, so the question is, find u naught, v naught and w naught. So, we start with the differential equations of equilibrium. for equilibrium. Okay. So, the first differential equation is del nx over del x plus del nxy over del y equals 0, but del over del y is 0. So, this simplifies to dnx over dx is equal to 0 or nx is equal to C1. Second equation is del nxy over del x plus del ny over del y equals 0. This simplifies to dnxy over dx is equal to 0. So, ny nxy equals C2, and the third governing differential equation is del 2 mx over del x square plus 2 del 2 mxy over del x del y plus del 2 my over del y square plus q is equal to 0. So, in this case q is 0 because the plate is not having any external transverse load, and also these partial derivatives with respect to y are 0. So, this equation simplifies to d2 mx over dx square is equal to 0. So, what that tells me is that mx is equal to C3x plus C4. Okay. So, this is what we get from the differential equations. Now, we apply some boundary conditions. We will not apply all the boundary conditions. So, we have C1, C2, C3, C4, and we will select some specific boundary conditions so that we can calculate the values of these constants. Okay. So, first we select nx plus is equal to n bar. So, we look at this equation. So, it says nx is equal to C1, and that is equal to n bar at x is equal to a over 2. So, C1 is equal to n bar. The next one is nxy equals C2, but at x is equal to plus a over 2, its value is 0 at x is equal to a over 2. So, C2 is equal to 0. The third thing is mx is equal to C3 x plus C4, but we know that mx plus is equal to 0 at x is equal to plus minus a over 2. So, this gives me C3 is equal to C4 is equal to 0, because I am applying two boundary conditions at x is equal to plus a over 2 and minus a over 2, mx plus is 0. Or let us do this explicitly. So, we first at x is equal to plus a over 2, what is it? Mx is equal to C4 plus C3 a over 2, and that value is 0, and at x is equal to minus a over 2, mx is equal to C4 minus C3 times a over 2 is equal to 0. So, these give us C4 is equal to C3 is equal to 0. Okay. So, once we have applied, so which boundary conditions we have applied? We have applied the boundary condition on nx, on nxy, on mx plus and on mx minus. We have applied 4 boundary conditions. 4 boundary conditions are still remaining to be applied. So, after we are done with these 4 boundary conditions, what we are left with is nx is equal to n bar, nxy is equal to 0 and mx is equal to 0. Okay. Now we develop expressions for nx, nxy and mx in terms of ABD matrices. So we will develop n, m, a, b, d relations. Okay. And before we do that, we note that because plate is cross ply and 0 to 92, a lot of terms in ABD matrices are 0. What are these terms? A16, A26, B16, B26, D16, D26, B12 and B66. All these terms are 0 because it is a cross ply laminate. Okay, this is important. B12 and B66 is also 0 for a cross ply laminate. So with this understanding, now let us write down what is the relation for Nx. Nx is equal to, so I will write it as A11 epsilon x naught plus A12 epsilon y naught plus A16 gamma xy naught plus B11 k x naught plus B12 k y naught plus B16 k x y naught. Okay. So this is the expression for Nx, and what we see is epsilon y naught is 0 because it is a partial derivative of v with respect to y. A16 is 0 because the laminate is cross ply. B12 is 0 because we just said that it is a cross ply laminate, and also ky is 0, and also B16 is 0, and also kxy is 0. Okay. So this simplifies to, and epsilon x naught is partial derivative of u with respect to x, but because the plate is semi infinite, it is du over dx, and the other term which gets involved is B11, and kx is what? Minus d2w over dx square. Okay. And the value of Nx is Nx bar. So this gives us, so from this we get, if I integrate this equation once and rearrange, what I get is A11 u naught equals n bar x plus B11 dw naught over dx plus C5. Okay. So let us call this equation 1. Similarly, if I expand mx, so mx is equal to B11 du naught over dx minus d11 d2w over dx square, because all other terms B16, all other terms involving epsilon y, gamma xy, ky and kxy, they will be 0. So this is the only term left, and this is equal to 0. Why is it 0? Because we have seen that mx comes out to be 0 in the plate. So we apply this condition, and when we integrate it once, what we get is B11 u naught is equal to d11 dw naught over dx plus C6. This is equation 2. So we have expanded on Nx, we have expanded on Mx, and next now look at Nxy. So, nxy is equal to, the only thing which is left is A66 dV naught over dx, all other terms drop out. So, this is coming from A66 times gamma xy, and gamma xy is d partial derivative of v with respect to x plus partial derivative of y u with respect to y. So, the other component is 0. So, this is what we are left with, and this is equal to 0. So, from here we get V naught equals C7 by A66. Okay. So, this is equation 3. So, now how many integration constants we have? C5, C6 and C7, you know, and we will get one more integration constant when we integrate W, because right now we only have derivatives of W, but before we go there, what is the value of C7? So, we look at this boundary condition that at x is equal to minus a over 2, V naught is 0. So, this means that C7 is 0. So, C7 also it works out to be 0. Okay. So, now what we are left with are two important equations which are coupled equations in u and dw naught over dx. Okay. So, if I solve for dw naught over dx from equations 1 and 2, so basically if I put the value of u naught in from equation 1 into the other equation, so what I get is from 1 and 2, what I get is B11 dw naught over dx plus C5 plus n bar x into 1 over A11 is equal to D11 dw naught over dx plus C6 into 1 over B11. Okay. So, this is, so I have eliminated u naught from here, and this is an equation only in dw dx. So, if I rearrange this equation, what I get is B11 minus B11 over A11 minus D11 over B11 dw naught over dx is equal to C6 over B11 minus n bar x over A11 minus C5 over A11. Okay. And if I multiply this entire equation by A11, essentially what I get is, so I am multiplying the entire equation by A11. So, it goes away from here denominator and it appears in A11, and it goes away from these two denominators also. So, what I do is, now I integrate to get W, I have to integrate this, to get W I have to integrate it. So, what does it imply? It means that W naught x, and this I can rewrite it as B11 square minus A11 D11 divided by B11 is equal to A11 by B11 C6 minus C5 minus, it is nx square over 2, there is an x here plus another integration constant C8. So, this is the expression for W naught, and this is actually n bar. So, what we will do is we will stop here and we will continue this discussion on this particular problem, case 5, and we will complete the solution for this case 5 or case E in tomorrow's lecture. So, thank you, and I look forward to seeing you tomorrow. Thanks.